Hey team, let's take a look at example A. So we want to identify the acid and the conjugate base pair, as well as the base and the conjugate acid pair. Okay, so what I'm asking you to do is to basically look at a chemical and figure out, is it acting like an acid, which will give a hydrogen away, according to Bronsted-Lowry, or is it acting like a base, which will accept that hydrogen? Now, the conjugate is just what it turns into after the reaction has occurred. So let's start with just identifying the acid and base. So when I look at HCN, take a look at maybe the root, that might give you an idea, and look and see what does it turn into at the end. And here I see it turns into CN minus. So you ask yourself what's happened, and what's happened is it gave away that hydrogen. So if it is a hydrogen ion donor, right, it loses or gives away a hydrogen. We can see that's what's occurring. The HCN is our acid. Now, where is that hydrogen going? Well, that hydrogen, right, is going to be accepted by the base, because Bronsted-Lowry's definition is really about one accepting, one donating. How do they react with each other? So if I look here, NH3, now I don't see a hydroxide or anything, but remember, not all bases have hydroxide. NH3 turns into NH4 plus. So how did I get an extra hydrogen? Why is it positive? It's because it accepted the H plus from the HCN. So NH3, by accepting that hydrogen, is acting like the base. Now, we can also label its conjugate. Now, you'll notice I drew the arrows pointing because this is going to make your work really easy. The NH4, because this reaction can go back and forth, that's what that double-sided arrow shows us. The NH4 in the reverse is giving the hydrogen away. And by definition, the hydrogen donor is acting like the acid, but this is not like the acid, but we call it the conjugate acid because when the reaction runs in reverse, it does actually behave, by definition, like an acid. And then the flip side to that, the acid, right, gave away the hydrogen, it became CN minus. Well, when this reaction runs in reverse, right, the CN minus is going to accept a hydrogen, thereby acting, by definition, like a base.